Suppose that we wish to estimate using a 95% confidence interval the mean age at which patients with hypertension are diagnosed. We randomly select 12 subjects with diagnosed hypertension and record the age at which they were diagnosed. The ages that we have there, we have 12 of them, those ones which are appearing. Assume that the age of diagnosis is approximately normally distributed with sigma being equals to 7.2. So we are going to find a 95% confidence interval using that given information there. So we have those ages there and the sigma 7.2. When you have normal distributions, the confidence intervals are of the form, the first one, x bar plus or minus z alpha over 2 multiplied by sigma divided by square root of n if sigma squared is known. If sigma squared is unknown and n is less than 30, then the confidence interval is the form x bar plus or minus t n minus 1 alpha over 2 s divided by square root of n. Then for the third case, if sigma squared is unknown and the number of observations is greater than 30, then the confidence interval is the form x bar plus or minus z alpha over 2 multiplied by s divided by square root of n. And the s there is the sample standard deviation. So in this case, we are going to use this formula here, this one that I've highlighted, just because our sigma is known. It's the one that we are given there, the 7.2. So that's the form of our confidence interval, and we have our sigma there. And for us to evaluate that confidence interval, we need that x bar. The x bar, that's the arithmetic mean. So we'll just add those ages that we are given, and there are 12 of them, so we'll divide by 12. That will be our n. So the x bar is 32.8 plus 40 plus 41 plus 42 plus 45.5 plus 47 plus 48.5 plus 50 plus 51 plus 52 plus 54 plus 59.2. Then we divide by 12, and that will give us 46.9. So that's our x bar. For this question, we are looking at a 95% confidence interval. The level of significance, the alpha, is 1 minus 0.95, which gives us a 0.05. So this level of significance, we'll use it when you're calculating this z alpha over 2. So we are saying our alpha is equals to 0.05. So we'll be having z alpha over 2 is z of 0.05 divided by 2, which is z 0.025. And you read this value from statistical tables, and to get that value there is 1.96. Our n is the number of observations. We are saying our n is equals to 12. And we are saying that our confidence interval is of this form. So I can write it here, x bar plus or minus z alpha over 2 multiplied by sigma divided by the square root of n. So I go on and substitute the values of the x bar, of the z alpha over 2, of the sigma, which is 7.2, and our n there, which is 12. So that would have our confidence interval there. It will simplify to 46.9 plus or minus 1.96 times 7.2 divided by square root of 12. So our confidence interval there will be from 42.8 to 51.0.